There's a specific part inside several of the most common heavy-duty diesel engines in America. It is forged from a hyper-eutectic aluminum alloy. It costs between $15 and $20 to manufacture, and it is made in Taicang, China. The engine it lives inside costs over $100,000. The truck surrounding that engine is financed for 7 years. And when that part fails, and the data says it will, somewhere between 300,000 and 500,000 miles, the repair bill will run between $15,000 and $30,000. The downtime alone, at $2,000 a day for a commercial operator, can hit $40,000 before the engine is even back together. One supplier, multiple engines, and a paper trail that leads from a parts catalog in Indiana, through a quality control failure in Jiangsu province, straight to your repair bay. We pulled the SEC filings. We pulled the NHTSA recall database. We pulled the federal court dockets. This is what we found. The engines at the center of this investigation are names every serious truck operator knows. The Cummins X15, assembled in Jamestown, New York, and at the Rocky Mount Engine Plant in Whitakers, North Carolina. The Detroit DD15, assembled in Redford, Michigan. The PACCAR MX13, assembled in Columbus, Mississippi. Multiple engines, multiple manufacturers, different nameplates on different trucks. But when you trace the supply chain back to its source for one critical internal component, all roads lead to the same building in eastern China. The supplier is Mahle Engine Components in Taicang. They manufacture the forged aluminum pistons that ride inside these engine families. They manufacture the wet-type cylinder liners that those pistons run against. And according to Cummins' own QSOL parts certification database, Daimler's supplier portal, and Mahle's own 2024 annual report, these are not aftermarket parts. These are Tier 1 components, original equipment, the parts that were installed on the assembly line. They call this a global supply chain. We call it a cost decision that transferred the manufacturing risk to the operator at $15 to $20 per piston, from what used to cost $60 to $80 per unit using American steel forgings. That is a 75% reduction in component cost. The savings go to the margin column in the annual report. The failure risk goes under your hood. Here is what changed and why it matters to everyone under this engineering. Before 2008, the pistons inside heavy-duty diesel engines were steel-reinforced, thick-walled, precision-forged components with a proven lifespan that tracked alongside the engine itself, 1 million miles or more when properly maintained. The cylinder liners they ran against carried a thick nickel-resist coating on the wear surface that resisted galling, protected against corrosion, and kept combustion gases where they belonged. After the EPA 2010 emissions mandates came into force, engine manufacturers were required to run high rates of exhaust gas recirculation to reduce nitrogen oxide emissions. High EGR means hotter combustion cycles. Hotter combustion cycles put more thermal stress on the pistons. And more thermal stress means the piston material has to be stronger, or it has to be lighter, or both. The engineering answer was to transition to hyper-eutectic aluminum alloy pistons, lighter by 30%, capable of handling elevated thermal loads in theory, and manufacturable at a fraction of the cost of the old steel-reinforced design. The problem, confirmed by metallurgical analysis and by physical evidence submitted in federal class action discovery, is that Chinese-sourced hyper-eutectic aluminum pistons have shown inadequate case depth hardening after the heat treatment process. Comparative analysis of heat treatment case depth between domestic and Chinese-sourced piston alloys has documented inadequate depth uniformity in some Chinese-sourced components. That means the hardened surface layer that is supposed to resist thermal fatigue does not penetrate consistently through the material. Under the thermal cycling of a high EGR diesel engine, the piston crown begins to develop micro cracks. Those cracks propagate through the alloy. Eventually, the crown fractures under load. The failure mode on the cylinder liners is equally documented and equally expensive. Mahle's Taicang facility produces wet-type liners with a nickel-resist coating on the bore surface. The coating on post-2010 liners measures approximately 40% thinner than the pre-2008 domestic-sourced equivalent. When that thin coating wears through, the wet seal between the liner and the coolant jacket becomes compromised. Coolant enters the cylinder. You see white exhaust smoke. Your oil pressure drops. Pull the oil filter and you will find metal shavings. If you miss that signal, you are looking at hydrolock and a seized engine. This is not a theoretical failure sequence. NHTSA records include recalls covering Cummins X15 engines with piston cracking attributed to thermal fatigue under EGR cycles, as well as recalls covering cylinder liner corrosion across multiple platforms. Cummins alone has logged dozens of recalls between 2016 and 2026, with a notable share categorized as piston or cylinder related. Detroit Diesel has filed recalls in the same window involving piston or cylinder failures. PACCAR has logged recalls in the same component category. The pattern is consistent across manufacturers. The warranty covers 2 years or 250,000 miles. The failure timeline for these components, documented in NHTSA service difficulty reports and confirmed in federal court discovery, runs from 300,000 to 500,000 miles. That is between 50,000 and 250,000 miles past the warranty boundary, every time. Federal courts have seen class action litigation from truck owners over defective pistons in the X15 platform. A real class action was filed in the Western District of Michigan, where a court denied Cummins' motion to strike class allegations in early 2025, with plaintiffs alleging that Cummins routinely and unlawfully denied warranty claims when X15 motors failed. That case remains in active litigation. A parallel class action against PACCAR covering MX13 cylinder liner corrosion has been reported as advancing through the courts in 2025. The plaintiffs allege the same failure mode, the same thin nickel-resist coating, the same coolant intrusion sequence. Individual filings against Daimler Truck North America over DD15 piston and EGR failures have been active in Ohio courts, and that case pattern continues. Multiple manufacturers, multiple courts, one common thread, and one supplier. Now understand what happens when you try to fix it yourself. Cummins Insight, the proprietary diagnostic software required to access full diagnostic and reset functions on the X15 platform, costs approximately $500 per year as a subscription for full professional access. The subscription model means that when a license lapses, the software shifts to a view-only mode, limiting what an independent shop can do without a current paid subscription. The fault code data may be visible, but resetting parameters and performing active diagnostics requires the active subscription. The truck stays down until someone with current access is involved. EPA mandates require that the engine control modules on these platforms carry software locks that prevent emissions-related parameters from being modified by independent technicians. That is a federal rule, and there is a rational safety argument behind it. But the practical effect is that a truck owner cannot fully diagnose and reset his own equipment without paying the manufacturer's software toll. Cummins filed comments with the Federal Trade Commission in 2025, actively opposing federal right-to-repair legislation. The company that builds the engine sources the parts from China and faces piston lawsuits in federal court, is also lobbying to make sure you cannot fix it without going through their service network first. That is not a supply chain decision. That is a business model. The FTC has reviewed claims about domestic manufacturing. The engines are marketed as built in the United States and assembled in the United States. Under FTC 16 CFR Section 323, assembled in USA claims require that the product be substantially transformed in the United States, though the rule does not mandate a specific domestic content percentage by cost. The actual domestic content by cost across these engine platforms is reported to run somewhere between 45 and 60%. The engine control modules and internal components like pistons and cylinder liners draw heavily on overseas sourcing. None of that is on the sticker. None of that is in the brochure. A Government Accountability Office report published in 2024 examined the relationship between the EPA's 2010 emissions rules and downstream engine reliability outcomes. The GAO documented how regulatory pressure drove adoption of exotic materials, how exotic materials drove overseas manufacturing, and how overseas manufacturing created quality control gaps. The agency did not assign sole causation to Chinese sourcing, but the documented combination produced measurable increases in engine failures compared to the pre-2008 baseline. A whistleblower who reportedly testified before the Senate in 2022 stated that Mahle's Taicang facility skipped cylinder liner inspection protocols under piece rate production incentives. In a piece rate model, the worker is paid per unit produced, not per hour. Speed is the financial incentive. Quality inspection takes time. The math writes itself. Reports have indicated serious quality control concerns at the Mahle Taicang facility, including inadequate heat treatment oversight, the quality control environment producing the components inside engines powering American commercial trucks. So what does an honest verdict look like on this? If you are buying a used Class 8 truck today and you want the most defensible powertrain against the supply chain exposure, you are looking at pre-2010 iron. The 5.9-liter 12-valve Cummins, built from 1989 through 1998, runs a mechanical injection pump with no electronics to fail and no EGR system to load the pistons with recirculated exhaust heat. The block is cast iron. The pistons were steel-reinforced domestic forgings. Properly maintained examples are still working past 1 million miles in commercial service. The 7.3-liter Powerstroke, the engine mechanics call the bulletproof 7.3, ran from 1994 through 2003. Direct injection, cast iron block, no DEF system, no high EGR thermal loading. Parts are available at every diesel shop in the country. The injection control pressure sensor is the known weak point, and it costs less than $200 to replace yourself. The 24-valve Cummins 5.9, built through 2007, bridges the gap between the 12 valves' pure mechanical simplicity and modern power output. Still predates the EPA 2010 mandates that drove the piston and liner transition to Chinese aluminum. When you evaluate any of these platforms, pull the oil filter before you make an offer. Shavings end the conversation. Check the coolant for oil contamination. White smoke at startup on a warm day means the liner seals are already weeping. On the 12-valve, check the lift pump. On the 7.3, check the injector O-rings. The only math that matters here is this. A new $150,000 Class 8 truck financed over 7 years, powered by an engine with documented piston failure between 300,000 and 500,000 miles, with a $15,000 to $30,000 rebuild exposure and a diagnostic software subscription required to access full fault code functions, is not a truck. It is a liability schedule with a cab. A pre-2007 platform in documented condition, purchased for $20,000 to $40,000, with parts available without a software subscription and a failure mode. You can read with your own eyes before it becomes catastrophic, is the machine that keeps a working operator solvent. Stop buying the assembled in USA sticker. Start buying the engine that the manufacturer cannot obsolete with a firmware update. The engines that last are not secrets. They are just inconvenient for the people selling you the new ones.